So today we are about memory, basically. A little bit of memory organization we are going to discuss. So can anyone tell me what is memory and what is CPU or processor? Yes. What is memory? In a computer, what is memory?
Ma'am, memory is external database where we can store data.
Database.
Ma'am, it is a place where we store data and instruction.
What is a processor?
A processor is a part of a system that gives the system extra potential to do work with much efficiency.
First of all, we have to understand what are the different types of memory and how they are connected with. Number one is input memory. It is connected with input-output devices, and it can be connected with the processor. So these are the two possibilities. Now, can you tell me how many types of memory are there?
Ma'am, two types.
Two types.
Yes. Ma'am, primary memory and secondary memory.
Primary memory and secondary memory.
Ma'am, internal memory, register, coaches memory, main memory, and secondary memory.
Okay, we'll see. First of all, you see this is a processor. Processor is directly connected with which memory?
RAM.
Internal memory.
What is the difference between RAM and ROM?
Ma'am, one is volatile memory and other one is non-volatile memory.
That's RAM and ROM.
So in this figure, please see, look at the figure. So we have secondary memory, okay, and from secondary memory, whenever something goes to the main memory. Okay, that is called paging. Because as pages, whatever information is asked for, that will be transferred to the main memory from the secondary memory by a process called paging. Okay, what is paging and all, we'll come to the detail later. As of now, just know that the main memory is connected with the secondary memory. Okay, the CPU or the processor is not directly connected with the secondary memory. The processor has connection with the cache memory. The processor can have connection with the main memory and with the registers. Okay, so as pages,
Ma'am,
yes,
ma'am, here what is the main memory?
I can't hear you. It is better you type.
Ma'am, what is the main memory here?
What is the,
Main memory here.
you please write down the question. Actually, in the class there is fan running and you're not audible. So what I was saying is, whatever question you have, please note down, you write down in the chat box. Main memory, yes. The secondary memory is connected with the main memory, which is volatile. Main memory is RAM, yeah, it is volatile. Okay. So as pages, the information, when it is asked from the secondary memory, the information is transferred to the main memory in the form of pages. Okay, and this process is called paging. And we can also call it virtual memory mapping. Okay. So this process can also be called as virtual memory mapping. Now everything cannot be stored in the main memory. That is one thing. Okay, main memory, the size is limited, whereas the secondary memory can be very, very large. So the main memory, which is the RAM, it has a limited space and it is also volatile. So all the information is basically stored in the secondary memory. From there, through mapping, it can come to the main memory whenever required. Okay. Now you see the main memory is connected with the CPU and it is also connected with the cache. So from main memory, information can come to the cache in the form of blocks or words. Okay. Now cache is a faster memory than the main memory. Okay. The speed of the CPU is quite high and it cannot match with the secondary memory or the main memory. So next kind of memory is the cache memory. Okay, it is also volatile. And from the main memory, through cache mapping, information comes from the main memory to the cache memory. This process is called cache mapping. Okay. And the size of cache is smaller than the main memory. And the processor or the CPU is directly connected with the cache. And they exchange information in the form of words. Okay. And the processor is also connected with a very, very high speed memory that is called register. Okay. So very, very less amount of information, one at a time, can be stored in the registers. Okay. Now suppose there is a program P and there is CPU. So this program has to run in the CPU, right? This program has to be executed in the CPU. Now, the CPU, the speed is in MIPS. That means it can process 1,000,000 instructions in a second. 1,000,000 instructions per second. Okay, so very, very high speed. So that kind of high speed cannot be if it is directly connected with the secondary memory. So the secondary memory cannot transfer the data to CPU at such a high speed. Okay, that is why there is a hierarchy that is maintained in memory. Okay, so the size you can see is decreasing and the speed is increasing from secondary memory to registers. So this is a little bit of memory organization. Please note it down in your copy, whatever you can see.
Ma'am, can you repeat the processor and the register again?
Please write down. Processor and register. Okay, so this processor, this is the CPU, and it is connected directly with the cache memory. Okay, from the cache memory, the information comes to the CPU in the form of words. Okay, and from the main memory also, if the main memory sometimes is connected with CPU, there also memory is exchanged in the form of words. And the processor is directly connected with another memory, very fast memory, which is register. Okay, it is directly connected with register and very, very less amount is present. Register is very, very fast and its quantity is very less. That means the amount of register present in a laptop is very, very less, but it is very, very fast. It can match up to the speed of a processor. That is why it is directly connected with the processor. And in register, very, very little amount of information can be stored regarding the processes that are currently running in the computer. That is the current processes which are currently processed by the CPU. Those process information are stored in the registers. Complete, everyone? Can I rub it?
Yes, ma'am.
So today I will give you a brief introduction about the memory hierarchy. What is the need of memory hierarchy? And a little bit about how we are going to start our lab. In the next week, we are going to start the lab. Okay. I told you that you have to install Java. It is a Java-based platform. So you have to install Java before we can start our lab. Everyone. So please do it by this week so that in the next week we can start our lab. And today, if possible, I will show you the interface. That is how it is done. Now you see, we are going to study about the memory hierarchy. So it is represented in the form of a triangle. Please draw this one. This triangle is the triangle of memory hierarchy. So at the top of the triangle, we have registers, followed by cache, followed by the main memory, then the magnetic disk, and then the magnetic tapes. Can anyone tell me an example of magnetic tape?
Ma'am, radio tape, magnetic tape.
Radio tape. Have you seen cassettes?
Yes, ma'am, that's one.
Ma'am, magnetic disc is the
Hard
hard disk.
drive.
Ma'am.
It is a kind of a memory. Okay. If you have seen the cassettes which used to be put in the tape recorder for listening to music. Okay, so one side of the cassette, when it was complete, it was turned around and the other side was put into the tape recorder. Okay, so there are two sides. In any tape, there will be two ends. This is the one end and this is another end. Okay, so information is stored in this tape. And now when this tape moves, the music plays. Okay, and when one side is finished, the data presenting one side is finished, then this cassette is turned around to play the other side. I don't know if you have seen cassettes because it's not very popular nowadays. But if you have seen a tape recorder in your home, which belongs to somebody in your home, okay. So that is an example of magnetic tape. And what about magnetic disk? Anyone?
Hard drive.
Hard drive.
Ma'am, DVD.
Yes.
DVD.
Yes. CD, DVD, all these are, examples of magnetic disk. And there is a different way of accessing the data from this type of disk. Okay. So we will see one by one. So first you note down access time. Access time, ACCESS, access time. What is access time? Basically, access time is the time required to access a particular memory by the CPU. Okay. So access time is the time required to access a particular type of memory by the CPU. And access time increases from this to this. That means what? The access time of register is least, then followed by cache, followed by main memory, followed by magnetic disk and magnetic tapes. Okay. Next is frequency.
Excuse me, ma'am.
Yes.
Ma'am, in hard drive, how the data is stored? Ma'am, it's like memory disk or in other way.
That is a secondary memory. Okay. Whatever you are talking about, that external hard drives, like, you know, you can buy external memory or you can buy a pen drive. These are all secondary memories, ROM. And they are used to increase the memory which is already present in the system. So it will give the computer a feeling like it is accessing from its own memory, but actually it is external memory. Okay. So it's virtual basically. Next is the frequency. Frequency here means how frequently a memory is used. How frequently a memory is used by the CPU. So it has been seen that register is most frequently used, followed by cache memory, main memory, and then the secondary memories. Okay, so frequency is of usage is highest for registers. So that is frequency. Next, we have size. That is size of the memory. So when we talk about size, register has the smallest size. Cache is larger than that. Main memory is larger than cache, and the secondary memory is larger than the main memory. So if I talk about size, that size increases downwards.
Downtrend.
And next, the last one is cost. Okay. So I told you register is the highest speed memory, followed by cache, main memory, and then secondary memory. So the cost of register is highest and cost of secondary memory is lowest. You see the cost of a hard drive? It's very, very less nowadays. One TV hard drive you can easily buy. So cost increases this way. So whenever you are going to buy a laptop, you will see that the more the size of main memory, the more is the cost of the laptop. Now the question is, what is the purpose of memory hierarchy? Please note down. What is the purpose of memory hierarchy? Okay, so first of all, you tell me, what do you think is the purpose of memory hierarchy?
And we can choose at our decision that what we need, what type of speed we need.
Can you speak a little louder? I'm not.
Cost efficiency.
faster,
Ma'am, it can be like it give different options to us as per our requirement, and it's also a cost efficient.
see, it is like there are different types of memory. Okay. And you can see that from the secondary memory, actually the secondary memory is storing the information. Rest of the memory is volatile. Okay. So you see the rest of the memory, though it is volatile, but they are very fast. Okay. And they are also costly. So if you are using too much of main memory, then first of all, it is going to increase the size of, cost of the machine. And secondly, it is a volatile memory. Okay. So if you cannot store a lot of data or the important data in the main memory directly. Okay. So that is, these are the reasons why, you know, different types of memories are required. The slower, then bit faster, more faster, and so on. And the faster the memory is, the costlier it is. So it is used in less amount so that the cost of the machine is not very, very high. So you can note down the purpose of memory hierarchy is to bridge. The purpose of memory hierarchy is to bridge the speed mismatch, is to bridge the speed mismatch between the processor to the slow memory, at a reasonable price. Okay. Now you see the
Processor to the slow.
these two are random access. Random access means you can fetch the data randomly from anywhere in the cache as well as the main memory. Okay. So in different places, the data can be stored. And you can access the data randomly. You don't have to follow any particular order to access the data in the cache and the main memory. Next is the magnetic disk. It is semi-random. It is not totally random access, it is semi-random access. Why it is called semi-random access? Let us see. So if you see a CD, it is like this. Okay. And it is said that there are different tracks over here. So one track you can access randomly. But from there, the data that you want to get from that track, for that you have to maintain the sequence till it is coming to the point that you want. So it is not totally random access, it is semi-random access. So in the track, you can come randomly, but from the track, you have to follow a sequence to move, like listening to music, right? You cannot, even if you fast forward the music, it is going to follow in the sequence. Okay, it will not jump from beginning to the middle. It will follow a sequence in fast forward order. So you can jump to a song randomly, but after that, if you want to fast forward, then that will maintain a sequence. And next is the magnetic tape. This is sequential. This is sequential access. Because you see in a CD, when you open a CD, you get a list of songs. Okay, you click on a song. So now you are on that particular track. So you have done it randomly by skipping all other songs, right? But if you are using a tape, like a cassette, and you want to go to the third song, then also you have to maintain a sequence. Okay, you have to make it fast, and it will just skip the first song, second song, and go to the third song. But it will go through the first and second song. It will not directly jump to the third one. Okay, so that is why it is a sequential access. Am I clear to you?
Yes, ma'am.
Okay. Now comes the implementation. Now again I have,
Ma'am,
yeah.
ma'am, magnetic disks and magnetics are the example of secondary memory.
What is the example of secondary memory? What did you say?
Ma'am, magnetic disks and magnetic tape.
All these are actually external memories. Okay. When you will learn virtual memory, you will be more clear about it. Okay, now I have to ask again the same question. That is how much you have learned in digital logic.
Nothing, ma'am.
Yes? Do you know flip-flops?
Yes, ma'am.
No, ma'am. No, ma'am.
Okay, so the registers are implemented using flip-flops. The registers are implemented using flip-flops, and the registers are really, really fast. Next one, the cache memory is implemented using static RAM. Or SRAM. And the main memory is implemented using DRAM. So it is your homework to go through the difference between flip-flop, SRAM, and DRAM and try to understand what is making this memory faster than this one and what is the advantage. Okay, just a minute. So that is introduction, brief introduction about the kind of memories which are present in the computer, and what is the hierarchy of the memory, what is the need of the hierarchy, how these memories are implemented, and how they are arranged. Okay. So this, after this, just a minute. Is it visible to you?
Yes, ma'am.
Yes, ma'am.
So this is actually the software that will be used for your lab. Here you can see the logic gates are there. OR gate, AND gate, NOT, NOR, NAND, XOR. Okay, so from here you can pick up the gates. There is input output. Here you have bit display, clock pulse, bit switch, digital display. Okay. Then you have adders, which we have, I think you have not studied in digital electronics yet. Adders, subtractors, this will come. So mainly adders are important, half adder, full adder. Other than that, you see RS flip-flop is there, D flip-flop is there, T flip-flop, JK flip-flop. So what you have to do is basically you have to pick up from here, establish the connection, and see and check if theoretically the tables that you have studied, like for AND gate, you have studied a table. So whatever table you have studied for a particular gate or particular circuit, whether it is true or not. And if you change the circuit, then what is going to happen? Okay. Then other components, we have decoder, we have multiplexer, we have comparator. Okay, we have ALU also, arithmetic and logic unit. So controller is there in control unit. In computer design, you have CPU and memory. So based on what is there in your syllabus, we are going to study these. And these are very small grids. If you want to increase the size of the grids, you can do it using this, and you can decrease the size of the grids using this. Okay. If you increase the size of the grids, then you can also just a minute. I might have some saved. It's not there as of now. Okay. So it is not there as of now. The programs, there are a lot of programs that we will do from here using these, and I'll show you how to do it. Okay. And this is the simulate button. It is basically a online simulator. Simulator means virtual platform for getting a view of something you do in practical, like in hardware. Okay. So in hardware, suppose you are using this gate, OR gate, AND gate, NOT gate. So suppose this is OR gate that I have taken. Now you have to establish, this is for connection. You have to establish the connection using switches, and there should be an output to display the bits. So this way you have to, go through all these kinds of basic gates. We can also create the OR gate using AND gate, NOR gate. So these are different types of things that we will study in the lab. But for using this, you need Java. Otherwise, there will be problem in installation. So I suggest you that you install Java and you set the path properly. Okay. Do all the, not just install all the settings which are required for Java. You do it completely. And in the next week, we will start with the CO lab and the data structure lab. For data structure lab, you please study dynamic memory allocation, pointer, structure, all these chapters very nicely. Okay. So this lab is going to be very interesting, but you also keep studying digital electronics parallelly, because you know all this actually comes from the concept of that only. This adder, subtractor, okay, in sequential circuits, combination circuits, all these things will come from digital logic. So study that subject very well, and then we will discuss.